In this video, we will be looking at the difference between simple interest and compound interest. But before we get into that, interest is money that the bank can give you for making an investment. For example, if you put a sum of money into an account that earns a certain percentage of interest at the end of a year or at the end of a certain time period, you will receive that percentage on top of what you already have in your account. But interest also has the negative side when you think about loans. You can get charged interest on borrowing money. So for simple interest, let's do a little example here where you have 5% simple interest per year. With simple interest, the interest you earned depends on the initial amount of money you place in your account. Even though your account will increase each year with the additional interest added, the interest that you are earning will depend on the original amount, which makes it very linear and consistent. So the initial amount of money that you put into your account, we call that the principal. So if you put $1,000 into your account, at the end of 1 year, you will earn 5% of 1,000. So if you take 5% of 1,000 by multiplying 1,000 by 0.05, you get $50. So when you add $50 on, at the end of 1 year, you have $1,050. In your second year, you get another $50 for that 5% of 1,000. So now you're at 1,100. And you keep adding on $50 per year so that your account increases from that original $1,000. Now in this scenario, you are assuming that you are not touching your account, you are not adding more money or taking money out. So simple interest is very linear. And you can look at this for the amount of interest, you are multiplying your principal amount, let's call that P, by the rate. So that 1,000 times 0.05. But let's say you're investing money for 5 years. You can just multiply that P times R by the number of years, and that way you'll know the total amount of interest that you are earning in a certain amount of time. And then you can add on your interest to your initial amount to get your final value. So if you take your principal and you add your interest, then you'll know your future value of your investment or your loan. Now, if you look at these two little equations that I just came up with, you should notice that this is a linear relationship. Even if I were to plot these points very roughly, I would start at, let's say 1,000, and then I slowly increase by the same amount each time. So it is a linear relationship for simple interest, which should also make you think of an arithmetic sequence if you want to go back to sequences. Now, let's look at compound interest. With compound interest, your interest is calculated based on what you have in your account at that moment in time. And your compounding can occur once a year, twice a year, every month, every week. There's lots of different types of compounding periods. So, if you start off with $1,000 in your account, in 1 year, you will earn 5% on that $1,000. So you get $50 added on. But in your second year, you're not calculating 5% on the original amount. You're calculating 5% on what's in the account right now, which is $1,050. So now you get a little bit more interest. You get $52.50 in that year. So when we add that on, you have a little bit more money. In the third year, you take this new initial amount and we take 5% of that. So now the interest is $55. You add that on and you keep applying your interest on the current amount. So this is actually an exponential value because you're always multiplying 0.05 on the previous amount. So for our equation, you're multiplying your principal by the rate, however many years or compounding periods there are. But if I just multiply by the interest rate the way it is, I'm just going to figure out the interest. I can actually do a compound interest formula where I get the final amount. So if I just add 1 to my interest rate, then I will take into account that principal value, just like when you think about calculating tax on an item. If you just multiply by 0.13, you'll get the amount of tax you owe. But if you multiply by 1.13, you'll get the tax on top of the original price. So same idea here where I do 1 plus I. And then it's going to be to the power of n, and n is going to represent the number of compounding periods. And it's multiplication because notice each time you're multiplying by 0.05. And that idea of multiplying should make you think of exponential, but also it might make you think of a geometric sequence because of that common ratio. So I'll make a note that it is exponential and geometric. And there we are. That's the main difference. And if I were to plot these points roughly, because my interest is a little more each time, it will slowly create this exponential shape. Now, that was just a little bit of an investigation. Now let's put it all together, learn what those key ideas represent. So for simple interest, we saw that we had two main formulas. One calculates the actual interest, so I equals PRT, and the other just calculates the final amount where you're adding your principal with your interest. So I'll just make a little note here. I is interest, P is your principal, which is your initial investment or your initial loan. R is your rate as a decimal, and T is the number of years always. And there we are. And A would be your final amount. So, like I said, a simple interest scenario represents an arithmetic sequence because it is linear. And the interest earned is constant because it always depends on that initial amount, regardless of the fact that the amount might increase over time. Then for compound interest, we only have one little formula here where we have our principal and then 1 plus I to the power of n. And notice I'm not using R and T anymore because there are different types of compounding periods. And I'll look at that in a minute. But before we do that, I just want to make a note that this represents a geometric sequence because of that common ratio, which means that the interest earned will change each year or in each compounding period. So for the number of compounding periods, it can be annually, where it's one time per year. At the end of the year, they look at your account and add more money. Or it can mean semi-annually, where we're talking about twice a year. Quarterly, 4 times a year interest is added. Monthly, 12 times. Weekly, 52 times. Bi-weekly means every other week, so that means 26 weeks in total. And daily would mean 365. Now, when something is compounded semi-annually or quarterly, pretty much anything but annually, your interest rate has to be divided by the number of compounding periods. So that I value is not just the percentage, it's that percentage divided by the number of compounding periods. So it's your rate divided by number of compounding periods. If your interest is getting compounded daily, you're not going to get 5% every single day. No bank would want to do that. So make sure you remember to divide that rate. And then same thing. With your N, it's not the number of years, because if your interest is compounded quarterly, that means your rate is being applied 4 times a year. So we actually have to multiply the number of years by the number of compounding periods. So for I, you're dividing to cut down on that interest rate. And for n, you're multiplying to get the actual number of compounding periods. So let's start off with a few examples. And we will start with simple interest. On your birthday, you get $1,000. So I'm going to highlight that. And you decide to invest it at 4%. That /A means per annum, so per year. Simple interest for 4 years. How much will you have in your account at the end of the investment? So we see the word simple interest, so we know what formula we will be looking at. And maybe at the beginning you want to organize your work a little bit. So that 1,000 represents your principal. Your rate is 4%, which we can write as 0.04. And then your time is 4 years. And we want to figure out how much we'll have in our account at the end of the investment. So first things first, let's calculate the interest by multiplying the principal by the rate and then by 4. And when we do that, we get $160 in interest. So because they want to know the account final amount, we will add that $1,000. So our final amount is the principal plus the interest. So we have $1,000 to start and we earn $160. So that means we have $1,160 at the end. And then make sure you write a therefore statement. Therefore, you will have $1,160 after 4 years. Okay, suppose you borrow $2,000. So now this is a loan at 6% per annum simple interest for only 3 months. How much do you have to pay back at the end of the 3 months? So our principal is 2,000. Our rate is 0.06 and our time is not 3. It's 3 months, so we have to turn the months into years. And we know that each year has 12 months, so we can do 3 divided by 12, which is 0.25. So now we can go ahead and use our formula to find the interest and then the total amount that we're going to pay back. So why don't you pause the video here, plug your information into your formulas, and finish this question off. So for the interest, you should have multiplied 2,000 by 0.06 and 0.25 to get $30 in interest, which means the amount that you owe at the end is the 2,000 plus the 30. So $2,030 is owed back. And therefore, you have to pay back $2,030. Okay, let's try one more simple interest that's slightly different. So you have $5,000 in a savings account that pays 5% per annum simple interest. You want to have $8,000. How long do you have to invest your money? So now, yes, they gave us the principal, which is 5,000. They gave us the rate, which is 0.05, but they did not give us the time. That is what we are looking for. Instead, they gave us the final amount of 8,000. And if they gave us the final amount, we also know how much interest this account must have earned. So if we just subtract 8,000 and 5,000, we get $3,000. So this account needs to earn $3,000 in interest in order to reach that final amount. So if we now go to our main formula, I equals PRT, we can replace I with 3,000, P with 5,000, R with the 0.05, and T we don't know. So now we can clean up that right side and do the multiplication, which we get 250 times T. And it's just a nice little linear equation. So divide both sides by 250 and you get 12 for T. So therefore, you must invest for 12 years. And for all three of these examples, I knew I had to use these little formulas because it had the word simple interest in it. Now, let's move on to compound interest. And before we do that, we're going to look at those compound interest modifications. So we're going to complete the table below. If the annual interest rate is 5% and the investment is for 10 years. So if it's 5% and we're dealing with yearly, then you're going to get 0.05 for your I. And the number of compounding periods, if it's yearly, is 10 because once a year. But when we go to semi-annually, that 0.05 has to get cut in half, which you can leave as a fraction, or if you want to turn it into its decimal, if it's a nice decimal, you can. So that would be 0.025. And for the number of compounding periods, if it's twice a year for 10 years, then we're multiplying 10 times 2 to get 20. For quarterly, 0.05 into 4, because this is 4 times a year. And you can leave the fraction or write 0.0125. I don't want you to cut any decimals, so if it's easier to keep it as a fraction, keep it as a fraction. And the number of compounding periods, it's 4 times a year, so 10 times 4 is 40. So I want you to try to finish off this table for monthly, bi-weekly, weekly, and daily, and then come back to the video to check your work. So for all the compounding periods, I multiplied 10 by the appropriate amount. So 12 for the monthly, 26 for bi-weekly, 52 for weekly, and 365 for daily. And then for the compounding periods for the interest, I divided that 0.05 by the number of compounding periods. So now let's try to use our formula and this knowledge of the modification. So you won $10,000 in a lottery. Being the math savvy genius you are, you decide to invest the money in an account that earns 2.8% per annum interest compounded weekly. So already I see the word compounded, so I know I'm not using simple interest anymore. How much will you have in your account after 5 years? And how much interest will you earn? So first thing, I know that my principal is $10,000. And now I have the interest and the number of compounding periods, not the rate and time. So my interest is going to be that 0.028, but I have to divide it by 52 because it's compounded weekly. And that's going to be a pretty ugly decimal, so I'm going to keep the fraction the way it is. And then for the number of compounding periods, I know it's 5 years, but for every year, I'm going to get 52 additions to my account. So 5 times 52 is 260 total compounding periods. So now my compound interest formula is P times 1 plus I to the power of N. So let's go ahead and just plug all of our information in. So 1 plus 0.028 all over 52 to the power of 260. So you can do this all at once in your calculator. Just be careful with your brackets and that fraction. So why don't you pause the video, plug this into your calculator just to make sure you get the same value as I do. Okay, for your final amount, you should get approximately 11,502.30. And you automatically have to know that you have to round to 2 decimals because we are dealing with money. So this is how much you'll have in your account after 5 years. To figure out the interest, we can take this total amount and subtract our initial investment of $10,000. So that means you earned $1,502.30. And now we can write a little therefore statement. Therefore, you will have $11,502.30 in your account, meaning you earn $1,502.30 in interest. And there we are. Let's try the next one. You get a $5,000 bonus. You invest this money in an account that earns 2.2% simple interest for 3 years. Then you take your money out and put it into an account that earns 2.2% per annum compounded monthly for 3 years. How much is your investment worth after 6 years? So this is a two-part question. So first thing, let's deal with the simple interest part because that's the first 3 years. So there, our principal is $5,000. Our rate is 0.022 and our time is 3 years. So why don't you go ahead and pause the video and figure out how much money you will have after 3 years of this simple interest. All right, so when you do 5,000 times the rate times the time, you should get $330, and that's the interest that would be earned, which means after 3 years, you will have $5,330 before you put it into that compound interest account. So for the next 3 years, now our principal is the new amount that we've just taken out of our original simple interest account, and it's going to be compounded monthly. So I have to take that 0.022 and divide it by 12. And then the number of compounding periods, well, I have 3 years and 12 times a year, so I multiply and I get 36. So from here, I want you to pause the video again and figure out the total amount that you have after another 3 years of investing. All right, so when you plug it into your compound interest formula, hopefully you got 5,693.30 cents, and that would be how much your investment is worth at the end of those 6 years, because we did our simple interest first. You took the money out and you took this money and put it into the compound interest formula for 3 years, and this is how much you will have at the end. All right. Let's try another type of question. How much do you need to invest today at 3.8% per annum compounded annually so that in 10 years you will have $8,000? So this is definitely our compound interest formula. But the thing is, I don't know my principal amount. I do know that my interest is going to be 0.038 divided by 1 because it's annually, so it doesn't change. And the number of compounding periods is 10 times 1, which is 10. And I know my future amount is 8,000. So in my formula, A equals P, 1 plus I to the power of N, I have everything except for P. So I'm just going to plug everything that I know in. And now, this portion here is just a number if you simplify it, but I don't want you to punch it into your calculator so that you don't lose accuracy. So I'm just going to divide both sides by this amount. And if you want to simplify the 1 plus 0.038 to 1.038 when you divide it out, that's perfectly fine, and that's probably what I would plug into my calculator anyway. So now you go to your calculator and plug this in. So I want you to pause the video here to make sure you are plugging it in properly. And when you do, you should have 8,000 divided by, open up a bracket, 1 plus 0.038, close bracket to the power of 10, and that should work well for you. So pause the video and then come back to check your work. So your principal amount should be approximately $5,509, $1,000.55. And your logic check here should be that your principal value has to be less than the final amount. And then, therefore, you need to invest $5,509.55 today. So same formula, you just have to rearrange it a little bit. Okay, last one. How long should you invest $1,000 at 6% per annum compounded semi-annually to double your money? So I see the word compound. So I know my principal is 1,000. I know that my interest is going to be that 0.06 divided by 2 because it's semi-annually. And that does actually give me a nice decimal. So I will simplify this one. I don't know the number of compounding periods. And I have to remember that if I want to know the number of years will be doubled for n. So I have to keep that in mind. And I know that my final amount should be double that 1,000. So that means 2,000. So now let's use our formula. And this time we're going to be solving for n. So 2,000 equals 1,000 times 1 plus 0.03 to the power of n. So this is now an exponential equation, and we always divide the constant out first if we have to. So we get 2 equals 1.03 to the power of n. And from here, we know that we would try to get a common base, but off the top of our heads, we can't do that. So you can do your guess and check, or you can do that little shortcut of log 2 divided by log of 1.03, and you get approximately 23.45. So that 23.45 is equal to n. But remember, n is not the number of years. We took the number of years and multiplied it by 2. So really, that 23.45 is equal to 2 times the number of years. So if I divide both sides by 2, then I'm going to get approximately 12 years. So therefore, it will take 12 years to double your money. And there it is. So make sure you look out for the word compound or simple to know what formula you're using. And make sure for compound interest, you are remembering to do those modifications for annually, semi-annually, quarterly, etc.